Okay, today we are going to review equivalent fractions, seeing them both as a picture model and then seeing them as a number model. So we're going to remind you that equivalent means equal, and the second word is fractions, which makes sense. So this is equal fractions. The visual model is what I want you to start with because I want you to see that they are equal. But in order to recognize some of the similarities of how to use visual models to represent number models is what I want you to focus on. So in this one, there is a total of 6 pieces, but only 3 of them are shaded. On this side, there is a total of 4 pieces and 2 are shaded. Now you should be able to visually look and see that the amount of shaded is the same, so they are equal. But what you want to recognize from the number part is that you can simplify the fractions. So in this case, it says 3 over 6, and this one says 2 over 4. Well, I need to recognize that both of those numbers can be simplified by breaking them into their factors. So 3 over 6 is the same as 3 times 1 over 3 times 2. There is no, it should not be, let me try these words. There is a coincidence that I put the 3 over top of the 3 because I'm going to remind you that if I have 3 parts and I have all 3 parts shaded, that is a total of 1. So every time I have a number over the same number, I can write 1. Well, what is 1 times 1/2? It is 1/2. And on this side over here, it's the same situation. I'm going to rewrite it as 2 times 1 over 2 times 2. Now you'll notice that again, I have 2 over 2, which represents a whole, which is 1. Well, what is 1 times 1? Or 1 times 1/2? It's 1/2. So does 1/2 equal 1/2? Yes. So that's the proof on why these are equivalent fractions. Now, looking at these pages, I am certain that you won't have much trouble with things like number 3. You can visually look and say, oh yeah, those are the same. And then you just write down what they are as fractions, whether or not they're equal or not equal. But problems like number 2 might be more of a challenge where you need to represent them numerically. So in this case, there is a total of 3 pieces. So I have 1 shaded out of 3. And in this one, there's a total of 8 pieces. The total goes on the bottom. And I have 1, 2, 3, 4 shaded pieces. Now 1 over 3, I cannot simplify or break it apart because the top number ends up being 1. So if I were going to rewrite it, I'd have to do 1 times 1 and 1 times 3. And that's just pointless because that's already going to be 1/3. Now the other side I can break down. This one will equal 4 times 1, and it will also equal 4 times 2. So I looked for the factor that they both had in common. And since 4 over 4 means 1, this one simplifies to be 1/2. So does 1/3 equal 1/2? And the answer to that is no. So we're going to put does not equal. That's going to be, this is your homework because pictures seem to be something that's a little easier for students. You are going to be expected to do the rest of that one at home, which means you will be doing, I believe it's this one, on your own or today in class. So, do you remember how in the previous one I tried to break it into pieces? This one already has a 1, so I can stop. Okay, but this one has a 5. So since since the numerator and denominator can be written as 5 times a number, I'm going to stop there. And 5 over 5 cancels and turns into 1. So the question is, does 1/3 equal 1/3? And the answer is yes. Let's go to number 2. We're still going to break these into the highest number that we can divide them by. So what do these two numbers both have in common? The numerator and the denominator. Well, they're count by 2 numbers, so I'm going to put a 2 and a 2. 2 times 2, 2 times 3. These two cancel. You're left with 2/3 on this side. And let's see what happens on the other side. Well, I still see count by 2s. So I'm going to do 2 times 4 on the top and 2 times 5. This is why we have our multiplication charts, so that we can identify the factors that they have in common. I know 8 is a count by 2 number, so I'm going to check it out. Maybe it's a count by 4 number, but 10 is not a count by 4 number. So since those have those in common, my answer here is 4/5. Are those equal? No, they are not. So we are going to put do not equal. Let's see. Go ahead and push pause. I want you guys to try. You can use your desks for the work, but then put the final answer on the piece of paper, and then come back and see if your answer is correct. Okay, I'm going to look at 7/3, and 7 is a prime number, which means I can only get it by doing 7 times 1, and 3 is a prime number, which means I can only get it by doing 7 times 1, so that guy has to stay exactly the way he is. 16 and 6, however, can both be a count by 2 number, so it's 2 times 8, 2 times 3. These cancel, and I end up with 8/3. Now, when I look at these two numbers here, are they equal? No, 8 is bigger, so I'm going to put a not equal there. On your papers, you need to show some sort of work on this side because I did work on the board. So I want to make sure that I see that you're doing something. All right, let's try it one more time. You guys go ahead and try number 4. Push pause, and then come back. 3/5 is, again, 3 is a prime number, so it's not going to change. 5 is a prime number, so it's not going to change. So this one just stays 3/5. But 12/20, I could do, let's see what happens if we see that it's just a count by 2 number. So this is 2 times 10, and this is 2 times 6. So if I eliminate that, that's good. But if I look at 6 and 10, did anybody stop there? If you did, that's okay, but you got to re-look at it again. Those are still both even numbers. They're count by 2 numbers. So it can be done again. This one would be 2 times 3, and this one would be 2 times 5. You eliminate the 2 and the 2, and you end up with 3/5 as your final answer, your simplified fraction. When I look at this, they are equal. How are we doing? Are we doing pretty good? Okay, so you guys can continue this on your own, and I will have this video, or if this class needs it, we'll continue on. I'm going to put the answers, but I want you to look at the work. There's number 6. It is correct. If you got it was equal. If you are a student that is just going to copy the work that I put on the paper, please make sure that you at least go through that effort. 9 and 4, it's not a count by 2 number. It's not a count by 3 number. They do not have anything in common, so I can't do anything with that one. These two, if I look on my multiplication chart, on my count by 3s, I can have a 3 out of both of them. This one is 3 times 5, and this one is 3 times 9. So I eliminate that, left with 9/5. 9/4 and 9/5 is not the same thing. All right, we'll go ahead and go here. These are count by 2 numbers, so I'm going to go ahead and put my 2/2. This is 2 times 6 and 2 times 4. Oh, I didn't recognize that there is an additional 2. So 6 and 4 still can't by 2 numbers. So I'm going to write it as 2 times 3 over 2 times 2. So that means this side is 3 halves. And 6 over 5 cannot be simplified because they have nothing in common. So it's not equal. Number 8. Oh, this one's fun because I see a 0 and a 0. I'm just going to cancel those. So 4/10 is 4/10. If I want to simplify, 4 turns into 2 times 2, 5 turns into 2 times 5. On this side, 2 times 2 and 2 times 5. And they're both going to end up being 2/5. So it is equal. All right, number 9. 7 over 2, those are both prime numbers. I cannot do anything with it. But this side, 21, 3, 7, let's see if there's a 6 in either one of those going down the multiplication chart. There is a 3, so this would be 3 times 7. This would be 3 times 2. So this one would also be 7 halves, which means it's equal. I'm going to go to number 11 just to kind of see. So I recognize that these have an 11 because I noticed that it's 3, 3 and 2, 2. So I'm going to change this to 11 times 3 and 11 times 2. That cancels. This side ends up being 3 over 2. Now on this side over here, I'm going to look on my multiplication chart and see what number across the top works. I believe they both have a 4. So this will be 4 times 9. I found it. And this is 4 times 7. So if I cancel this, I have 9 over 7, which does not match the 3 over 2. So they are not equal. We're going to do the, oh, what happens here on number 13? That's not a fraction. I have to make it a fraction like so. This one comes into 3 times 1, and since 18 is also 3 times 6, look, do I have the same thing? Yes, I do. Let's do 15. All right, 8 over 3, their count by 3 numbers don't match with 8, so it won't simplify anymore. These have a count by 2, so I'm going to do 2 times 5 on the bottom and 2 times 16 on the top. I'm left with 16 over 5, which does not match. So there's the answer to that one. All right, let's see here. We're going to go to 10. Notice we're on number 10. Now, this is a cheat way. Which number is my biggest number? In this case, since my biggest number is in 2 different places, one's the numerator and one's the denominator, it doesn't work. But I will show you how that works. 2 and 9 cannot be split into something that they both have in common, but 18 and 4 both have a 2. And what we see, 9 over 2 and 2 over 9, they are trying to get you by just flipping it upside down. Number 12. I'm going to start with this side over here because it looks easier to me. 9 is 3 times 3. 15 is 3 times 5. So now I need to check the other side. Ooh, my cheating of my multiplying by 9s. Has any of you heard that cheat by holding up your hands and doing a problem? Please let me know how many kids have done that. Hopefully I'll get to raise my hand and show you how it works. But I know that they're both factors of 9. This one is 9 times 5. This one is 9 times 3. And look, they end up being the same. 1/3, this side is done. I can't do anything with it. But this one has 13 times 1 and 13 times 2. Eliminate it. Does 1/2 equal 1/3? The answer to that is no. One more problem. 9 over 7, they're both prime number. Well, 9 is not a prime number, but it doesn't have 7 in it. So this one is done. It's as far as it can go. They both end in 5, so I'm going to start with 5s. So 5 times 9 and 5 times 7, eliminate. This one is equal. I will zoom out so that you can see all the answers. And feel free to check, ask questions, and remember that the other part is homework.